So the next presenter is Dr. Jung Park from Intellian Technology. He will make a presentation which is titled on multi-orbit, multi-band Satcom Terminal Technologies. Yes, let me introduce him briefly. He is working for Intellian Technology since 2012, and he worked for KT Satellite Business Department up to 2011. Yes, let's welcome him.
Thank you for a good introduction. And it is my pleasure to be here for presenting here with title of the multi-orbit and multi-band satellite terminal technologies. This presentation is actually elaborating how Satcom terminal technology evolved under context of ecosystem change in satellite industry. Recently, emerging HTS satellite constellation and the NGSO constellation. The presentation will proceed as in the listed in this slide. The keyword and ecosystem change and the future Satcom technologies, flat panel antenna technology if the time is available, or skipped. And then finally, I will come to a conclusion. Before dive into a presentation, I would like to ask audience understanding that presentation time is very limited, but the contents of the slide deck is covering quite wide range of the technology. So I have no choice but explaining most of the slides very briefly, but I will try to my best conveying a key message without loss in a delivery. In this slide, the keyword in Satcom industry are introduced. The coexistence of GSO and NGSO constellation and the multi-frequency band usage, and extension of the mobility Satcom and tool for filling digital dividend gap and merging mobility Satcom to land-based service. This keyword is the well-known in the satellite industry and also have a significance for representing big change in the ecosystem and leading into technology satisfying the new trend. With given keywords, I'll jump into a main body of the presentation. Ecosystem change for the Satcom. In order to understand what's going on in Satcom industry, we need to see ecosystem change recently happening for satellite industry, as in the list here. As first, multi-beam based HTS, it is taking over conventional satellite system. And next one, the emergence of NGSO constellation, extending satellite business into corner of the globe, including polar region. And then another big change is the extending Satcom service into ocean and air in truly global level, which inevitably use the multiple frequency band from L band, C band, and KU band, KA band for optimum service area. Thanks to what was mentioned previously, commercially or politically motivated initiative actually drive low-cost satellite service comparable to optical land fiber quality services for unserved area worldwide, more than around 40% of total population nowadays. And then let's take a look at what these more detail. As a form of HTS with a multi-beam, maybe it is easy to understand what is this. This slide is showing that the traditional Satcom beam is a regional basis, quite a big single beam. But right-hand side is a global spot beam system. It is composed of the small beam covering quite a large portion of the Earth, and is taking over the conventional satellite system like a beam left one. So it is quite similar with the frequency repeater pattern as in the land mobile communication, which is leading a frequency utilization breakthrough and enable small size antenna with the higher throughput is possible. And it is the LEO satellite constellation example, the SpaceX and the Iridium and the O3B. The Iridium has provided service in the market already last 2 decades, and the O3B services in several years. But through global lies the NGSO satellite program initiative, deploying 100,000 satellite low Earth orbit satellite constellation to cover the entire globe with the land fibers quality data service like SpaceX and the OneWeb or some other operators are proposing. It is just the taking of the ground or will be in the near future. And then another aspect of this is the currently available the service platform proposed or going to launch for LEO space constellation. So I don't need to explain detail one by one. So, but this slide is conveying message that the NGSO is very close to the life of ordinary people. So it is quite promising. And then as a key differentiator for NGSO Satcom system technology compared to GEO Satcom system, handover process between satellite is required. It is like a land mobile service, and this seamless transfer between two satellites require quite different transmission standard compared to conventional one. So recently, this transmission concept was successfully implemented and tested with the dual antenna system or flat panel antenna system. So previous slide are actually talking necessary satellite operation concept or network architecture, but as most important elements, it is the service cost. As most dominant one, lowering manufacturing cost for space segment will make a land fiber quality Satcom system possible. So in other words, space cost for data transmission should drop to $0.7 per gigabps. So current technology breakthrough have changed satellite manufacturing method into modular and mass production, so which allow the satellite manufacturing costs down to this level. So everything is ready to jump into another level of innovation in satellite communication arena. So up to the last slide, ecosystem was discussed. From this slide, I would like to discuss how future Satcom service will be. This slide is explaining how a land Satcom service will be, or what type of the technology will be adopted to support the future services. In a nutshell, land Satcom mobility service will be complementary to land-based mobility services such as government vehicle or emergency vehicle. But for more large-scale level land fixed service comparable to land 5 quality will be dominant service with the LEO constellation. To support this service, dual antenna terminal and phased array-based flat panel antenna technology will be adopted for minimum or high-end B2B services. Still, dual parabola reflector type antenna will be dominant, but for consumer-level services, flat panel antenna technology is baseline. And this slide explaining how the maritime Satcom service will be and what type of technology will be adopted to support future maritime service. Maritime service itself is mobility services. So in a summary, safety-related GMDSS supporting L-band service will be sustaining as before, but the high data rate true global maritime service will be deployed with a multiple combination of orbit and frequency, meaning GEO, MEO, LEO-based service with the utilization of KU band and KA band frequencies. So technology adopted will be, it should be multiple orbit tracking capable and KU, KA band capable with a single feed system. However, flat panel antenna technology for maritime will be very limited because high-level throughput requirements and also performance degradation due to severe ship motions. And then this slide is explaining how aviation Satcom service will be. Aviation service is the most fastest growing service sector and become most service for airliners, which is capable to provide 500 megabps or up to 1 gigabps throughput each individual airplane. Currently, gimbal-based flat panel antenna is widely used, but in the end, phase rate-based flat panel antenna will be most promising technology in the future aviation Satcom because of low air drag and the very high efficient for NGS or constellation. But there is some issue in complicated type approval process. It is delayed introduction of phased array antenna. So gimbal-based flat panel antenna will survive quite a long time. And then this one is a little bit different technology sectors. It is definitely out of my expertise area, but still worthy of addressing very briefly. Current transmission standards for satellite services are dominated by DVB-X or its variant. However, 3GPP or its variant will be positioned in lieu of low latency and line of sight propagation characteristic in NGSO system. So I'm expecting it will be incorporated in 6G transmission standard in near futures. So that's for how the Satcom service will be in the future. For now, what is the flat panel is important. If time is available, I'll briefly discuss this one. As this slide says, why the FPA flat panel antenna is important, because let's see what is important element for NGS or Satcom terminal. In a summary, it should be very high reliable, because it keeps tracking LEO satellite continuously for lifetime or that long time. And then it is low cost enough that people in unserved area should be able to access. And also, this technology satisfies a general requirement of NGS constellation. Maybe that element, as I mentioned, that anybody can imagine that the FPGA technology is suitable for this application. So in this slide, I present the three-type technology, which are typical technologies, potentially promising candidate for future use. I don't spend more time to explain how it works due to time limitation, but if further information needs, there are available information, tons of information already in public domains. So it is conclusion. The changing satellite communication service environment, as reviewed in slides so far, the pure Satcom technology converged as listed in the slide. First, it should be multi-beam terminal technologies supporting GSO and NGSO, and then also reflector type or flat panel antenna type. But the most important one is it should be a low cost for easy access, and also harmonize the transmission standard between the mobile and satellite system for fiber optic level service quality for Satcom system. That's the conclusion of my presentation. So thank you for listening. I wish it will help understanding the new trend of the Satcom system. Thank you.
Thank you. Thank you for nice presentation, Director Park. So he made a presentation about a lot of antenna technology, so such as a flat panel antenna for satellite communication.